Hello, I'm recording our CSCI for 52 memory analysis. Okay, for today's class, mainly we'll focus two things. The first, we of course like go to study about lecture related to the debugging, so something related to it, and then as a follow up on our Tuesday class, actually the lab, so we went through some like advanced dynamic analysis, and we showing okay how can we use debugger and do the reverse engineering. So we will try to execute okay for the debugger we're running on the VM. So maybe to my maybe I guess because the Apple, if others Apple user, if you experience some like similar issue, then let's check out to figure out some issue. How can we fix it? Okay, and if you are working fine, then you can follow steps. Okay, and this is what you need to do. For the lab, I will show you. Okay, but I'll put it by the rest of the lecture so you can look at it later. It's mainly about like start the sim. Okay, simulate the network connection, and then open the browser to check the execution. Okay, and then see the operation after we execute the instruction line by line. Okay, so more details for the debugger. So it will be like using either hardware or on the software side, so we can use the exterminate the execution of another program. Okay, and when we try to doing the debugger, like running debugging, so using so it includes one thing is disassembler. Okay, so this more like it's just like static snapshot of like what the code looks like before execution. This like disassembler because those that we call the binary or executable. Okay, so they are the file already like and already disassembled before because they already assemble, so we have to like disassemble it. Okay, so we look like how it looks like. And for the debugger, so it's helping us to look at being a dynamic snapshot of okay, how they really do. Okay, I'm doing the execution. So those code like every instruction actually they um running. Okay, and they load into CPU memories. Okay, so one by one. And for the debugging, including the styles, including is calling the source level. Okay, so we can debug while coding. Okay, so most of the machine execution, so they will of course running to the source code line. Okay, so each line, and then we can also allow setting the breakpoint at the source code line. Okay, so this one, I think if you are writing program, you should be pretty familiar, and then you can set a breakpoint like maybe if you want to see okay if you execute until this statement, okay, and then you want to see okay will you pop out any error or that will it execute correctly. Okay, it meets your expectation, so we can set a breakpoint. Okay, this one is on the source level, so I think most of you kind of familiar if you're after you're writing several programs. And then for the assembly level, so this one will be like strictly operate at the machine instruction level. So that's why when you open a debugger, okay, and doing debugging, you will see all those like will be in a machine instruction. Okay. It's mainly like we are making debugger using for our malware, okay, and doing the malware analysis. But most of the time when we receive those files, okay, they're all executable. Okay, they are binary files. So we try even we when we did the advanced static analysis, we try to open it using Cutter. Okay, Cutter to look at. They try to disassemble it. Okay, and or like try to make it look like more assembly language. But even exactly okay, or we can see the language they're using, and for our like at assembly level, also for debugger, also it shows right here. So if you look at the page, so it's more likely is the running on the instruction. So you can see on the CPU, and then how it looks like on the memories. Okay, so all those that A's X registers like EXP and then ECX, okay, EDX, EBP, ESP, like all this, and then of course like EIP, okay, the extension instruction pointer, and then maybe the CL thread, okay, like this, all the condition. This is how it looks like. And for the user mode, so mainly we can like debug one program through another program, so all in the user space. So let's say if we're the only debugger or like GDB or the one we using the X32 DBG. So this one is the debugger we're using, or in the kernel mode. So it will be more like this debugging on like on a kernel require a second machine. Okay, so we have to configure the target OS and then allow those like kernel to do the debugging. Okay, so let's say the Win DBG. Also, this one is like on the kernel mode, but among what you see is like user mode, and then later in next chapter you will see what's the only DBG. Okay, but for this one we mainly look at the X32. Okay, so you can refer to the slides. And for single stepping, so when we execute, when we execute one machine instruction or the source line at a time, okay, every time, so we try to step over, so we can try to like call the function. So if they call a function and execute at once before control, and then return back to debugger, so we can like checking all those and next instruction. And if you want to see, we will do the like step into. Okay, so we will look at those like calls. So they will go to the functions follow. Okay, so they enters the code E. So from one machine instruction at a time. So they will just like check all the steps. Okay, so if you remember, if we show the debugger and then we say okay, there's a debug mode and including step into step over. Okay, so will be run. Okay, so after let's say we start and then we can, so right here we start run. Okay, so after run it execute, and then you can execute like step over or like step into. But of course we need to find the execution code, and then we can try like call the D word pointer right here. And then I will step into, let's see if I can execute, restart. Okay. Okay, I have some, but luckily I have some issue on this VM. So I will show you one more time. And then also after we step into, and then we have a stepping out. Okay, so we execute until the return back to the calling function. That means it is finished. So this one is like we call a step. Okay, mainly for the our example, the dropper. Okay, the dropper, because we try to download it. Okay, from URL. So when you call, so there's a calling function. So those call function. So we can try to like step into it. Okay, so we can like try to see okay what's the full length of those machine code, like what's the call function, and then later after we compute it, so we can like step away, so we can return back from the calling function. Or if we're not going to like execute, so we can like just those the call function execute at once. So before we return, so they just runs off them, so we will be like step over. Okay, and also last time in the lab I talked about the breakpoint. So the software breakpoint is doing try to stop the execution. So whenever those like program which to a particular virtual memory address, like if you remember last time you're able to find, let's say, the dropper, they will the droppers will allow you, okay, actually once you have internet, they will say okay, once you have an internet connection, and then they will create the report. Okay, so that one actually is the virtual process they create based on the report, like the error report like on the Microsoft. Okay, so and if we want to check those instruction and those like call function, okay, then we can set the breakpoint. So we will try to stop by before we execute it, or next time, or like when we have like because as well we say I say it before, because when we execute instruction it's one line by line. Okay, in case you need to to restart it, okay, or like you have to like roll back, okay, to certain instruction and to look at it one more time. Then we have to like go through all the instruction one by one. Then maybe we'll set the breakpoint. It can help us like to like go to certain breakpoint and then execute and look at it again. So that's why it can help, like we can examine the state of the machine at the like some critical execution point. So because we can like reach the particular virtual memory address, okay, to of that instruction. Okay, of course we can set multiple breakpoints, and then right here. Okay, so you can set multiple breakpoint, and then later after you set it, then you can find it right here. Okay, when you click on the breakpoint. Okay, so here's the idea of it. And here, the example, let's say we have the string XOR. So we always say loss XOR, and then we have the EDI, okay. And then we will point to some like garbage at the memory location right here, address, and actually we try to decode it and then 0x90. So we remove the and ASCII string. Okay, so we pass it XOR EDI, okay. And then they maybe like try to like break after the maybe we say like break it right here loop after the loop, so then they can examine the memory for the ASCII string. Okay, so maybe we can set it right here, or like if we have the low library A, so maybe like being produced like with this XOR decode. Okay, so if they need to doing this, then we can better to let's say the breakpoint, and then right here, they will try to like break the function pointer. So when they try to call for the discover like address, okay, so you can set because this one moving the from the EBP, but the agreement and then move it the ECX, okay, and then they will move the EDX at the EX and then call the EX, okay, this one maybe. Also, they have the file creation to the discover files right here. Okay, so maybe pushing they will you can like create a file that will right here. So you can set in a breakpoint. So when you set a breakpoint right here, and then we will execute. So we can look at those like parameters they're passing. Okay, so before you see, maybe they will try to push the parameters, right? So we can look at the parameters so it can match. So here's like for mail analysis, pretty similar when we look at the core function. Okay, so if you open the dropper the using the debugger and then to examine the dropper. Okay, so the dropper right here, and we of course like we will try to looking for some like core function. Okay, and then if you find the core function, and sometimes they will pass the parameter, so they will like have a like perform certain like push. Okay, and right for some of them they sometimes when they call they will like push the value into it, so we can like check how many parameters, so they could going to like push it in. Okay, and also right here, and sometimes they will try to execute files like encryption, so we can see they maybe try to get the data and then call the get data, and then maybe like try to encode the data and call the function, and also later maybe they will like send it. Okay, and all these the steps from this screen that's just telling you when we try to get the putting the breakpoint, we will try to see. Okay, so maybe after they call to get data, so what the values, then you can set the um um set a breakpoint right here. Okay, or like if you want to see what's the encoded data, and then stop what's the next step outcomes, then also you can set the breakpoint right here. So all this will be the example, also like building a sense like maybe in which instruction or certain keywords, if you need to like look into, then you have to put that breakpoint. Okay, so this the more likely is the sense like, okay, when do you where do you check, or like kind of similar if you have the source code or waiting on the source code, when should you set the breakpoint? Okay, or like at which certain function code or like in certain statement you think you should like set a breakpoint rate to check it. Okay. So right here will be showing like just more details and say, okay, so maybe implement the software breakpoint, then they will try to overwrite the opcode. So if you know the opcode operation code, like saying for certain um instruction, okay, right here. So the debugger will restore from the overwritten byte like upon the continuous, then they will know, okay, after breakpoint, if you're okay, then you can break. Okay, so it will be like this. And next part, we talk about the hardware breakpoints. So they will be like dedicated register. Okay, so they may be stored on the virtual storage. They can be like set to be break on the SS rather than just on the execution stage. Okay, so we can set the memory like watch point on the data. So read or write, or we can implement like so there's a for hardware registers like DR0 to DR1, 2, 3. Okay, so they can modify by the running programs. And sometimes the the malware they can disable. Okay, them on the reverse engineer. Okay, this also is possible. And also like countermeasure, we can use some general detection frame. Okay, in the DR7, so that we can trigger if the breakpoint. So any then move involve the debug register. So because we need to be careful, like if the malware they try to like avoid this, so maybe we can try to find this or this register. If you see right here, the RC 1, 2, 3, and 6, 7. So 7 will be right here. So this one, we can see like trigger those like breakpoint. Okay, and then also we can set some like called the conditional breakpoints. So the break only if a certain condition is met. Okay, let's say if you want to like here is that from the slides, you say to get the process address function. For us, we'll be calling if we still remember in the advanced static analysis. Okay, so if you remember, we will try to call, okay, the function like this. And so if the some like let's say the address parameter, like say register value, okay, so if they try to like implement let's say some normal software breakpoint or but the debugger can check those like condition. So they will automatically like condition if not made like this. And some modern debugger can extend this to even a Python script controlling debugging. So like Python script will be like more advanced. Okay. And here one more like if you know when we writing sometimes we do have some exceptions. So okay, and then how can they like handle exceptions? So those exceptions will pass the control to debugger. Okay, and sometimes they will try to trap the flag in the first register register. So they will try to like division by 0. So it will getting like invaded memory access. What's the problem right here? So there may be when the interface with the like exception handler with they need to run it. And if one thing is that if the malware okay already embedded okay in the three handler, so this one, and then the debugger will use this one to implement the software breakpoint. Then there's an issue, right? So if let's say the print right here, print where job is done, and then within the integer three handler, then it will cause the problem. So there's some exception passage. So that's called a first chance and then the second chance exception. So if the attack the debugger, so they already attach it, so they will get the first chance control. If the debugger doesn't want it, so the program allows it to handle the exception. If the program it doesn't handle those exceptions, okay, so they will just will crash. So the debugger will get a second chance to handle the exception again. Okay, so this is a second chance. Of course, malware they may like intentionally try to trigger the first chance exception to determine the environment. They go through the timing side channel. They'll measure the time and see if they invoke the in3, and also and then they will try to measure the time again in in3 handler. So they still have some problem, but it's like analysis. Okay, so that's why we need to like looking for different alternative way and like try to inspect. Okay, is it okay if they do so? If let's say for the modify the execution. Okay, so maybe we can use the debugger to skip the function by like changing the EIP directly. So if you remember the director, we say the extended instruction pointer, so will be the next one we're going to execute. Right here, because when I try to execute, so calling a mem here's with the location 77. Okay, go back right here. Okay, so far right now the EIP it ends right here will be section 1B8. Um, is a 1B33F0 right here will be the ID, and then that's why when you see that every time when I execute it and then run it, okay, so it just like kind of like stop right here F0. Okay, so it will stop right here, jump, and then to end it. So it always like go down to this part. Okay, and then it just like finished it. And suppose it should be like start from entry point, but so here's like study real when I want to show you. And there is skill function and changing the EIP. So we say the EIP, it will be next instruction. So when they invoke the function directly on the argument, so you choose, okay. This is really useful in the debugging, okay. Because the metamorphic married, so they will like behave like differently. So maybe under different circumstances. So maybe let's say if you start the debugging, okay, or like if you're running on a VM, okay, that means that if you still remember for some malware, they will try to detect, okay, is this program is running under the virtual machine? If yes, they may be not doing anything. Just like they will when they try to execute, they will check the internet connection. So they of course they can check all these things, or they locate some like nuclear enrichment facility like that. Okay, so different circumstance, different condition, different environment. So they will have like some way. So they will modify the execution. Okay, they may change it. Debugger can be like set to like trace those like branches of the metamorphic like code. So we can try to they can change it. That means when we look at those instructions, they say okay, if they check the condition, okay, they will jump into some location. Okay, that means you are able to know. Okay, and here just a example. So it's like local base. Okay, so will be the metamorphisms like to the language setting of the target. So in the beginning, you try to get the system default LCID. Okay, so they have a function call, and they will check again the value. So again, like cell 49 right here, cell 411, cell 21, and then C cell 4. So they will try to determine like which code um to execute. Okay, so they move it and then they will based on the catch call. So once they move it, okay, so they have the EBP. If you remember the stack, so EBP we're adding it. Okay, so they will just jump depends on okay which condition. So start from a 49 411 okay right here and 421 okay or CCO4 okay right here. So they just compare. Okay, if no, they just jump it. Okay, they will execute. So it's the way they try to do. And just like showing right here, so there's a until story, the notepad there. So there's a most like the worst thing like cyber attack in the history. So the Russian military almost like certainly respond to this the district in just 2017 cyber attack. Just like something share. So this one is like the military malware just direct at the Ukraine, and but it's like indiscriminately like hitting the civilians target everywhere. So that's like what happened. And quickly cover because we didn't go really showing using the only DBG. Okay, so this one just like slightly background, so it can like use for the malware analysis and expose the development. Okay, so later they just like purchased by the immunity and then focus in the immunity debugger. Okay, so it supports like also the Python API. Also, it's like free version. You will see it right here. So there's some screen, so you can launch it, and then just like try to open the file, and then you can see maybe like we create it and load the file right here. There's a full main Windows December registers. Okay, so we show that like integer, floating point, stack, and then the memory dump. So it's pretty similar with the our debugger right here. So let me close it. Okay, now go right here. Let's open it. Okay, resign to community. So you can like did it. Okay. Do the URL and then I should open the files and I will just go to desktop, and of course I already have a exe file. Of course you don't have to recheck it, so it will execute and run it. Okay. Let's see if we are running on this one. If you can see. So right now we have a prohibit date, so we cannot accept. So might have some problem loading it. Let's see. Okay, but still you can see the screen right here. So pretty similar. We have the instruction. Okay, and then something on the register. So all those like register right here, and then the hex dump. Okay, and then the stack. So the layout is pretty similar to the 32 DBG. Okay, so have a pretty similar way we can do it, and then we can choose the parent pair, and then we have the we need to execute for the same, so we can execute it, and then we can like execute until the return debug. Okay, or execute like till it's and have some get user code, or we talk about the step into step over. Okay, and right here, and then also we can set the breakpoint and then using a double click, so it's pretty similar to the one we're using, the 32 dbg. Okay, and if you want to like attach into a process, you can look at it. So once we attach it, so you can use the view tool like the memory, look at the list of memory. Okay, we're creating it, and those load library will load into the process address like this. Like you can maybe then like kernel one, kernel 32 DLL, NT DLL like this. Okay, you can just look at this like what they contain. And so far, I will of course, like we have the rest of part like talking about different like the threads right here. So there's some like process. If you remember, we have like multiple threaded, and those like malware can inject those like the root threads like to execute the code. Also, they can hijack it. Those like legitimate threads to execute code too. Okay, um, then we need to like think about like, okay, maybe how many threads are there like in the debugger, or like where those the instruction pointing to. So we need to like figure, okay, then we can use the view and then check the thread right here and right here, and then you can look at the thread. Okay, so there's some show you how many threads. I'll try to enlarge it. Okay, so when that's over will be one, and we'll close it. And also we have the that right here. So there's a slightly different. So right here, if you set any like breakpoint, okay, of course I went out, I have some issue loading it, so it doesn't look very well, but it's that you can like double click to set the breakpoint, so you can do it in this way. Or somehow if you want to check the memory map, so right here, okay, so they will try to checking, okay, maybe those that work on the devices, and then the hard drive and Windows System 32, okay, or like work on the kernel 32, okay. So all the simulation, so we can find um attached to that memory map and also the thread, okay. And also there's some issues that when we execute code, then we can think about, okay, should we like step over or step into it? Then we can think, because sometimes when the malware like make really mess up over the step over because they already execute. So when they have a step over, okay, so step over code instruction. So we set the breakpoint and then the next instruction after the code. So those malware can use we call that the telco. So they like maybe never return back. So they just execute itself. Okay. So let's say right here, the example, if they call instruction, they may never return back to the XOR. Okay, they never compare after they call this instruction. And so far we stop by this part and continue that for the next lecture. And I will giving you the time. Okay, you can like work on the following just slightly recap about what we did really long time ago for our dynamic analysis. If you remember dynamic analysis, we're running the INESIM. Okay, so if you forgot, and let me just let you one more time, tell you one more time. Well, now I'm running it, and then maybe I'll start a new terminal. And one thing after you install the INESIM, okay, if you don't have it, you can install it. After you install it, then you can edit the configuration file. Okay, and this is INISIM config. Okay, um, once you get into it, mainly because okay, so you have to make sure, because for the connection you have to change your network adapter to host only. So no matter it's the Ubuntu, okay, or the Windows, they are all host only. So I can show you right here. So both of them, they are all host only. Okay, so no, and they will have their own IP address right here. Let me show you the why let's checking. Okay, so when I look at this, so this one supposed will be um the 192.168.84.131. So this one is that belongs to this like VM image IP address. So I just modify it. So there's a one is called service by address, and another one is called a DNS. So the DNS, let me go down right here. So you can modify your DNS. Okay. So once you save it, so if you update save it, then you can go back here, and so you can just execute and run it. Okay. So after you run it, and you will see you run it in different port, right? Okay. And then you just need to come back to your Windows one. Okay. So the Windows one, either way, will be okay. You can try like the proxy. The proxy you can set like um after you lost a, okay, here just like reminding you, because if you don't have an internet connection yourself, should be the IP address will 192.168.84 upon 130. Okay, so this one is 131, 132, kind of same somewhere. And what you need to do, you can change the proxy. So the proxy right here, I just like added it within proxy. I put in the Ubuntu IP address and port 80. Okay, and then I save it. Of course, also you can change the IPv4 the DNS. So either way is also is okay. And of course you can like test it. Let me close it. Okay, so once you test it, when you type the IP address on this side 192. Okay, 191.38. So when I hit it, okay, so if I hit this one, because it's just at port 80, so it will be showing, okay, it's the default HTML page for the INESIM HTTP. That means your connection is okay, working fine. And after you're working okay, in the slides we talking like another one, but for our lab, I recommend using the 32 dbg. So you can open your 32 dbg and open the files. okay, and you can pass, because this one, if you remember, even the files as the malz, okay, malz, also you can execute it. So either way will be fine. So I can show you right here, so you can open it. Okay. After you open execute, actually it's like you can see a pop-up window. That means that it try to execute this part. And one more thing, right here, let me. Now right here you can like start the open the workshop and then observe it. Of course, you may need to like restore or like before you taking all this step, you need to take a snapshot, and every time when you execute, like maybe like observe it and then open the workshop to observe all this connection. And you can see, okay, so sometimes they will try to like connect it and then see the package right here. And that's pretty good, okay, for like checking. And let me just start it one more time. Let me see. Okay. Continues without saving. Okay. And then I will try to restart it, execute, and there's some pop-out, and let me stop it. Because my you see one of the from the entry point EIP, it just directly like after we try to go debugging overload it, we are try to run it, and after running, suppose like if you are able to see they will go to the entry point and then one by one, but to mine it just like just skip to the end. So when I cannot look at this, so hopefully if we run some function I can try to find right here. Okay, so maybe if you are able to find it, then hopefully you can see they will try to calling the dropper was the connection and create the file. So after we execute, and also you can examine the directory under the public. So you see the under the this file C, we have the user public. Okay, so after the execution, you should see there's a files. Okay, and I don't mind I couldn't. It just jumped to the IP just jumped to the end, so I couldn't really execute. So maybe let me try one more time. Okay, I already open a file, so always they start with the beginning like pause. So once you set up the breakpoint, so you can like just like run it. So every time they will like if you already set the different breakpoint, then you can, let's say right here we have the breakpoint. If I set pause it, and then let's see right here. Maybe I try to create a breakpoint. I see I will try to call the function and then ntdll, and if I can able to like pause it, then you can see something. We try to call the location. Okay. Okay, right here. And when you like drum, and sometimes if you need to restart it, and I want to see run, and I can able to pause it. Okay, so when on my I cannot really show you how it looks like. I wish like if you try to execute, then you can see. And let me open the workshop. Okay, so you see the connection. Okay, and let me restart it, and I will execute the files. Okay, let me try to narrow it down. Let me close it, and then I can contains this anything, and I can execute the files. Let me just restart when I try to execute it. Okay, let me restart it. quickly, and then I want to see if I execute the dropper right here. Okay, so it comes out and then you stop. So your tasks are right here. So you need to find. Okay, so when they try to connect it, and then which port you try to connect, and they were sending to the connect to our iNetSIM. Okay, and also better to observe when they create, if you remember when we execute it, so it will try to create the report file. Okay, but right now I feel that my this one the defenders that bought the function bought the execution, also it just like jump to the end. So I have some problem I cannot show you. But suppose that originally once you set it, like set up all the connection like correctly, and then when you try to execute and open the let me close it quick without saving. Okay, so when you open the debugger right here, the debugger x32, and knowing the file, so you will start you will able to see start from the entry point and execute, go to the next one. Okay, so you'll see all those execution like what we observe from the static analysis. You will see all the files. So, and also you can compare when we try to execute the advanced one. So we can compare to the cutter app. Let me open it and just let it from the desktop. Okay, right here, can open. Okay. So suppose that when we open this file, you see from the entry point, and then let me switch it. Let me open a little bit bigger and move it. And how you see, okay. If you remember, like when we disassembly, and then suppose that in the beginning, though, from the entry point, and then we execute the main. So we will execute the main. From the main, you will see that maybe passing the string. Okay, Mozilla. So Mozilla is passing the push. Okay, and when you execute the instruction one by one, you should see all this. And also they will try to open the internet open. So when we execute past this one, and if from the Wireshark, you should able to observe this part. Okay, and when you keep like running the execution, like running the instruction one by one, then you should see another one. After they open it, they will try to, you will see they try to push right the under the public document, the create file CR 433.101 like .exe. So that's like what they're going to push, and they usually they create the folder. And all this like the process you can observe right doing in the instruction, and then you can use the Wireshark to observe it. But unluckily, right now I cannot show you right here. I have some version, but that's what you expected, like when we running on the debugger. Okay, and you will see, and then in the real time and compare with the cutter. Okay, so using a cutter, you will see, okay, in each instruction when they execute, so when they try to push the parameters, and then you will see the change on the which is the was the EPP at the moment, was the EAX, or like sometimes when they try to push the value here would be the four parameters like for the internet open. So when they push all this, okay, and then when they call the function, you can step into the call function like internet open. So what they're going to pass. Actually all this we can observe using the debugger. Okay, so which you can do it and run it. Okay. And so far, and just what you need to do to compete is that you have to finish this part. Okay, connect to the internet, or like show me the observation compared with the cutter. Okay, compared to this part, and then when you execute on the debugger. So also when you step into it, okay, that was the observation you have. Okay, of course, try to find the file state once you try to execute. So if you go to the location, okay, so you know the once they're under the public documents, okay, do they create the files? you should able to see it. Okay, so try to find it and then try to take a snapshot and showing, okay, are you able to find it like this? Okay, so right here, so if I would execute it and then you will see the CR like 43310.exe, and that's you able like to see after you execute. Okay, so all this will be the observation and doing the analysis, and here's the process, like actually from the binaries we call executable, and then doing the reverse engineering, go back to like the assembly format of in the machine code. Okay, and also using the debugger to set the breakpoint. So to look at something interesting, let's say if you see the internet open, you can set the breakpoint. Okay, try to create the files. Okay, and then of course you maybe set a breakpoint, or sometimes they will have a say call the function, or pushing the directory. Okay, or like shell execution. So you can like put in the breakpoint and then look into it. So there's like we have some like build up some sense, like look at something thinking pretty interesting. Okay, then we can look into it, step into it and look at it. Okay, so what kind of action instruction they are going to execute. And so far that's it will be for the first part. We finished like talking about the debugger. Okay, and then the second part will be showing what you need to complete as the rest of the lab. Okay, you should able to submit. And for the next, I will talk about your coming assignment. So will be the because this one we have the, let me cancel it. Okay, just remember there's another one you need to analyze. Okay, so you need to like open the 2-3 challenge question. Okay, right here, of course there's some question right here, the answer, but for this one you need to observe. So you need to start with the basics that they, and also the dynamic analysis, and then how can we perform the advanced one, advanced static analysis, advanced dynamic analysis. Just like basically you just use all the application tools for analyzing. Okay, and just to answer those questions. Okay, so it may help you to have some idea like doing the mail analysis and how can we do the reverse engineer. And so far will be like we will finish right here, and next time we will come back like keep on talking more about the breakpoints. Okay, and that's it. Thank you so much.